grade 10 students. In this quarter, you will examine and determine the number of possible ways of doing certain tasks or select objects from a set. Moreover, you will demonstrate an understanding of key concepts on combinatorics, particularly permutation and combination. This learning kit features a different mode of thinking when one encounters situations that require decision-making, one that is more disciplined than guesswork. Under combinatorics is the fundamental principle of counting. Counting techniques are used to identify the different possible ways of completing a task. A common counting technique used is the tree diagram. A tree diagram is a picture of all possible outcomes as an event unfolds. Let us consider the following examples. Example number 1. A student is choosing between sciences S or math M as a course of study and intends to enroll in UP, DLSU, or ADMU. Use a tree diagram to determine the different ways a course and a school can be chosen. We need to take note that there are two ways involved in accomplishing this task or in completing this task. And these are, first, choosing the course of study, and second, choosing the school to enroll in, such as UP, DLSU, or ADMU. Our first step is choosing a course of study. Our student can either choose studying sciences S or math M. For the next step is to consider the school to enroll in. For our school, if our student will choose to study sciences, he will have three options of school to choose from: UP, DLSU, or ADMU. In the same way, if our student chooses to study mathematics, he can choose to enroll in one of the following schools. He can choose to study in UP, DLSU, and again we have ADMU. Now, our outcomes are the following. If our student chooses to take up sciences, he can study in UP. So we have S and UP. You can also choose to study sciences in DLSU or sciences in ADMU. Then, if our student chooses to take up mathematics, he can take it in UP, math in ADMU, math and DLSU. Math in DLSU or math in ADMU. Okay. Our tree diagram shows us the different ways a course and a school can be chosen. And our outcomes are the following. We have sciences in UP, sciences in DLSU, and sciences in ADMU. Then we have mathematics in UP, mathematics in DLSU, and mathematics in ADMU. This tree diagram shows that with our options, two options for course of study to choose from, and three options for school to enroll in, there are a total of 6 combinations a course and a school can be chosen. For example, number 2, a coin is tossed 3 times. Use a tree diagram to determine the different possible outcomes. This situation involves 3 steps. First toss, second toss, and the third toss. It is also important to take note that a coin has 2 sides, head and tail. For our first step, for each toss, we have only two possible outcomes, either a head or a tail. You can have head or tail for our first toss. Then for our second step, which is the second toss, if a head comes up for the first toss, we can either have still head or tail for the second toss. And if a tail comes up for the first toss, the second toss can either be a head or tail. Now, for our third toss, again, we still have two possible outcomes, either a head or a tail. So let's say head comes up for our second toss, then the third toss can either be again head or tail. If the second toss is tail, its third toss can either be again head and tail, head or tail, and the same for the rest. We have head or tail, and again head or tail. Now for our outcomes, we can have first outcome would be H, 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 meaning head for the first toss, head for the second toss, and head again for the third toss. Then next we have H, T, H, H, T, meaning head for the first toss, head for the second toss, and tail for the third toss. Then we have H, T, H, H, T, T. Then T, H, H, T, H, T, 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 H, and T, T, T. Where T, T, T tells us about first, second, and third toss are all tails. The tree diagram shows that tossing our coin 3 times will generate 8 outcomes. And if we are asked to determine the chances of getting exactly 2 heads after the third toss, our tree diagram shows that 3 out of 8 possible outcomes give exactly 2 heads, namely HHT, HTH, and THH. So that is the chances of getting exactly 2 heads after the third toss is 3 out of 8.